Many electrical faults hide in plain sight, fooling continuity tests and bypassing unloaded voltage checks. But voltage drop testing, performed with a circuit under real load, exposes what other tests can't catch. In this lesson, you'll see how it works and how to apply it on a real diagnostic path. A circuit fault may show as either an open circuit, where current can't flow, or a short, pulling voltage straight to ground. But many real-world issues are partially resistive connections that only act up under load. Voltage drop testing can reveal voltage lost across these hidden resistances, while ordinary tests might show nothing wrong. Voltage drop testing measures how much voltage is lost across a connection while the circuit is operating. A good connection should have almost no voltage drop, even under load. If resistance is present, like a corroded wire, bad ground, or faulty connector, the voltage measured across that suspect spot will rise as current flows. To perform a voltage drop test, place your meter leads across the connection you want to test while the circuit is on and loaded. For example, to test a ground, put one lead on the load's ground side and the other on a known good chassis ground. Expect less than 0.1 volts for a healthy ground. If you measure a higher drop, like 0.5 volts or more, you found hidden resistance. Repeat for power feeds and signal circuits as needed. A continuity test, or checking voltage with the load unplugged, might show the circuit is fine. But these tests don't prove the connection's ability to carry real current. The wire strands may be mostly broken, or a connector may only pass tiny current. Only a loaded voltage drop test will reveal if there's enough hidden resistance to cause real-world faults. In a real repair, you might start with a code or an obvious symptom. Check for obvious opens and shorts. Then run voltage drop tests on both power and ground while the problem is present. A high voltage drop points you to the precise connection or wire segment that needs repair, ruling out unnecessary parts replacement and guesswork. A classic error is seeing a normal voltage or good continuity and replacing a part without testing under load. This can waste time and money if the real problem is a hidden high-resistance connection. Always prove a circuit fault by voltage drop while it's carrying normal current. Remember, voltage drop testing under load confirms whether every part of a circuit can really carry current, not just pass basic checks. It's a core step for reliable diagnosis on modern vehicles. By using voltage drop testing in real diagnostic sequences, you'll catch hidden faults and make every electrical repair faster and more reliable.